Okay, Module 3, Part 1. This is solving word problems and also solving systems of linear inequalities and linear equations. So we're going to first start off with translating some word problems into symbols and solving. So the first one says, write an algebraic equation and use it to solve the problem. 3/8 of a number is 24. So it's good to know some of the key words. The word of usually means multiplication. Is usually means equals. So in this problem, the equation is what we'll write first. It says 3/8 of a number. So 3/8 of means to multiply. So of a number, we don't know what the number is, so we're going to use a variable, and in this case, x. So 3/8 x, so that's 3/8 of a number is means equals, and again, in this case, -24. So the first thing is to write the equation. Next, we're going to solve. So anytime we have a coefficient, that's a fraction, so in this case, 3/8. In order to solve, we need to make this a 1x, excuse me. So to do that, we multiply by the reciprocal. So we're going to multiply both sides by 8/3. So on the left-hand side, of course, this reduces to just a 1x. Now, on the right-hand side, what I do is make -24 a fraction, and I reduce. So I'm reducing 3 goes into 3 one time, and into -24, -8 times. So now to get my final answer, I multiply straight across. So -8 times 8 is -64. And 1 times 1 is 1. So -64 over 1 is simply -64. So the number is -64. My next example would be a new youth sports complex is being built in Erie. The perimeter, so we know perimeter is the distance around. The rectangular playing field is 340 yards. The length of the field is 6 yards less than triple the width. So let's first make a little drawing. So we know we have 2 widths and we have 2 lengths. So to find the perimeter, we add the distance around. So it would be length plus width plus length plus width would equal our perimeter. So that'd be adding all the distances around this figure. So it goes on to say that the length, so I'm going to write the length, L, is, remember is means to write equals, 6 yards less than triple the width. So it's not 6 minus. When it's 6 yards less, that's going to come at the end. So the -6 is going to come at the end. Triple the width. So triple means 3 times the width. Okay, so now when we look at our formula, L plus W plus L plus W equals P, we can substitute 3W minus 6 in for L. So we would have 3W minus 6 plus W plus 3W minus 6 plus W equals perimeter, and they give us the perimeter is 340 yards. So now let's combine like terms. So we have 3W plus 1W plus 3W plus 1W. So 3W plus 1W is 4W plus 3W, 7W, plus 1 more W gives us 8W. Combining our constant, we have -6 and a -6. When we combine that, it gives us a -12, and that would equal 340. So our next step is to isolate our variable. So we're going to add 12 to both sides. So 8W would equal 352. So to find W, we're going to divide both sides by 8. So 352 divided by 8 is 44. So we know our width is 44. So W equals 44. Now to find our length, all we need to do is substitute that 44 into W, where we have L equals 3W minus 6, because it says the length is 3 times or triple the width minus 6. So to find the length, we're going to take 3 times 44 and subtract 6. So 3 times 44 is 132. And 132 minus 6 is 126. So the length would then be 126. So keys would be to draw your figure, write down the formula, and then fill in the information given in the problem. The next problem, we're going to write an algebraic equation for the following problem and then solve it. It says the population of a country in 2015 was estimated to be 321.1 million people. This was an increase. So an increase means it's going to be added of 27% from the population in 1990. So what we do is we start out by defining our variable. So in this case, we're going to let 1p equal the population in 1990. So the population in 2015 is an increase of 27% of the population from 1990. So our population in 1990 was 1p. There was an increase, so we add 0.27. So we're going to express our percent as a decimal, 0.27p, because it's a change or an increase of 27% of the population in 1990. And that's going to equal the new population, which is 321.1. So now we combine like terms. So 1.27p equals 321.1. And then we're going to divide both sides by 1.27 to give us p. So you'll take 321.1 and divide it by 1.27. And that gives you 252.83. Just pay attention to how many places they want you to round to. So if they want you to round to the hundredths, this would be our answer. They wanted us to round to tenths. It would just be 252.8. Our next example, very similar, but in this case we have a decrease. So it says a town's employment statistics shows that 930 of its residents were unemployed last month. This is a decrease, so that means it's going to be a subtraction problem of 25% from the previous month. So we're going to again let maybe 1p equal the number unemployed in the previous month. So now to set up our equation, we have the number that was unemployed in the previous month. Now again, a decrease. So minus 0.25 times p, and that will equal 930. So now we subtract. 1 minus 0.25 is 0.75p equals 930. So when they ask you to write the equation, they'll take either this answer or this answer. And our last step to solve, we're going to take 930 and divide it by the 0.75. So that tells us 1,240 were unemployed in the previous month. Our next example. May decided to invest $15,000 of her retirement fund conservatively. She invested part of this money into one account that pays 8% and part into another account that pays 6%. Last year, she earned $1,020 in interest. How much did she invest in each? So we don't know how much she invested at 8%. So let's go ahead and said, let X equal amount invested at 8%. Okay. So we know that she invested a total of 15,000. So if she invested X at 8%, she invested the remainder of the 15,000 at 6%. So we're going to let 15,000 minus X equal the amount invested at 6%. So this 15,000 minus X represents the remainder of the money. So how do we set up the equation? Well, the amount of interest you earn is the percentage times how much you invested. So we change 8% to a decimal. So 0.08x is how much interest she earned at 8%, because she was making 8% and she invested X amount, plus at 6%, she made 0.06 times the amount she invested, which was 15,000 minus X. And that equals the total interest earned. So the amount interest earned was 1,020. So now you're going to use the distributive property. So we're going to have 0.08x plus, we're going to multiply 0.06 times the 15,000, which would be 900, and the 0.06 times the minus x, which would be minus 0.06x, and that would equal the 1,020. Combine your like terms. So 0.08 minus 0.06 gives us 0.02x plus 900 equals 1,020. We're solving for x, so we're going to subtract 900 from both sides. So 0.02x equals 1,020 minus 900, which is 120. And then we're going to take the 120 and we're going to divide it by 0.02, because we're solving for x. So x would equal 6,000. So what does 6,000 represent? Notice in our original statement, we said let x equal the amount invested at 8%. So that means $6,000 was invested at 8%. So how much was invested at 6%? It says 15,000 minus x. So when we take 15,000 minus the 6,000, that gives us 9,000. So that means that $9,000 was invested at 6%. Notice, very important, when I add these two values together, the 6,000 and the 9,000, it equals the $15,000 in the original problem. So your final answers should add up to the total amount invested. Next problem. Although it doesn't have anything to do with money, we're going to use the same principle in order to set up this equation and solve. So it says A landscaping company needs 120 gallons. So that's the same thing as us investing a total of $15,000. 120 gallons of 23% fertilizer to fertilize the shrubs in an office park. They have 30% and 20% fertilizer. How much each should be used in order to make the mixture? So it says let X equal the number of gallons of 30%. So I'm going to write that down anyway. So let X equal the amount of 30%. So we're mixing that with 20%. So how much of 20%? Whatever's left. So it's 120. Remember, it's the total minus X is the amount of 20% used. Okay, so now we set up our equation. So same thing we did before. We're going to express the percentage as a decimal. So 0.30x plus 0.20 times 120 minus x equals, now notice we're making a mixture that's 23%. So it's going to be 0.23 times the amount. And the amount that we're making is 120. So notice the similarity. Here we have 0.30, so that's percent times amount. Then 0.20, which is the percent times the amount, equals the total percent times the total amount. So now we're going to use the distributive property again. So we have 0.30x plus. So now again, we're going to multiply the 0.20 times the 120 and the 0.20 times the minus x. And then we're going to multiply the 0.23 times the 120. Combine like terms. So 0.30 minus 0.2 is 0.10x plus 24 equals 27.6. Isolate, so we're going to subtract 24 from both sides. So that gives us 0.10x equals 3.6. So you're going to take your 3.6 and divide it by your 0.1 or your 0.10. So x equals 36. So again, what does that mean? That's why it's important to write down the statements at the beginning. X equals the amount of 30% used. So they're using 36 gallons of the 30%. How much are they using of the 20%? Well, they're using 120 minus x. So we're using 120 minus, we found x to be 36. So we're going to take 120 minus 36, and that gives us 84. So we are using 84 gallons of the 20%. So very similar to what we did in the money problem. Okay, this section also, we're solving what we call systems of linear equations and inequalities. So what we're doing is we're looking at two or more equations or inequalities and finding what we call the common solution. So we're looking for a value of x and y, if it exists, that would be a solution for both of the two equations given. So there's three different methods we use. We use the graphing method, we use substitution, and we use the addition or the elimination method. So I'll go over at least one of each type. So again, keep in mind, we're looking for a common solution. So there's three possibilities. The three possibilities are this, that we're going to have one common solution. So there's going to be exactly one value of x and y that would be a solution to both. The second possibility, that there's no solution. So that means there's no value of x and y that would be a solution for both. And the last is there's going to be an infinite number of solutions. So that means there's going to be a whole bunch of different combinations that could work. So let's start and look at graphing systems of equations. An equation means you have an equal sign. So step number one is to put it in slope-intercept form. So the first equation is already in slope-intercept form, so we're going to go ahead and graph that. So remember to graph. We have slope-intercept form, which is y equals mx plus b. So our starting point, remember, is our y-intercept. So in this case, our y-intercept is -2. So we're going to start by putting a point on -2. Our slope, the coefficient of our x, is 1/2. So the change in the rise over the change in the run. So from our starting point, we're going to go up 1 and over 2. Okay. And so with that, we're going to draw our line. Okay. So the next is an in-slope-intercept form. So we have 2x plus y equals 8. So we have to put it in slope-intercept form. So we want y to be by itself. So we're going to subtract 2x from both sides. And this gives us y equals -2x plus 8. And remember, for graphing purposes only, we're going to express our slope as a fraction. So here we begin at our y-intercept, which is +8. And our slope, the change in the rise, is -2 over +1. So from +8, we go down 2 and over 1. So again, what we're going to do is draw our line. And what we're interested in is the place where the two lines have a point in common, or where they intersect. So these two points, these two lines intersect at the point 4, 0. So that means our common solution is 4, 0 for this problem. That means if I plug in 4 for x and 0 for y, it should work for both of these equations, and that would be your check. Our next problem, we have 3x plus y equals 4 and 2x minus y equals 6. So again, we're solving the system by graphing. So the first thing that we need to do is make sure we put these in slope-intercept form. So here we have 3x plus y equals 4. So I'm going to subtract 3x from both sides. And y would equal -3 over 1x plus 4. So that's my first equation. For my second equation, I start with 2x minus y equals 6. I'm going to subtract 2x from both sides. This gives me -1y equals -2x plus 6. And then to make this a positive y, I'm going to divide everything by -1. So y would equal a negative over negative is a positive, so 2 over 1x, and a positive divided by a negative is a negative. So -6. So your next step is to graph both of these. So I start with the first equation. My y-intercept is 4. My slope is -3 over 1. So from 4, I go down 3 into the right 1, and I'm going to connect that with a straight line. I'm going to come to my next one. The y equals 2 over 1x minus 6. So I start at -6. My slope is 2 over 1. So from there I go up 2 and to the right 1. And again, I connect those 2 points. I'm looking where the two intersect. So again, when you have straight lines, you'll be able to see more accurately. These will intersect at the point 2, -2. So if I were to plug 2, -2 into both equations, it should give me a true answer. So that would be your check. Okay? Our last example, we have y equals -3x plus 4 and 3x plus y equals 6. So I need to put them both in slope-intercept form. Since the first one's already in slope-intercept form, I'm going to graph that. So I put a point at +4. My slope is -3/1. So from here, I go down 3 and to the right 1. And I connect the points. My next task is to place the second equation in slope-intercept form. So I'm going to subtract 3x from both sides. And this gives me y equals -3x plus 6, or -3/1. So here I start at +6. My slope is -3/1. And notice my lines are parallel. So if my lines are parallel, then there's no solution. How do I know my lines are parallel? Remember the definition of parallel lines. Parallel lines have the same slope. So we know that equation 2, we get y equals -3/1x plus 6. Equation 1 was y equals -3/1x plus 4. Notice our slopes are the same. If your slopes are the same and your y-intercepts are different, that means your lines are parallel and you'll have no solution because the lines will never cross. So remember, there's 3 possibilities. One solution, which we had in the first 2 examples. No solution, which we have here. If we have an infinite number of solutions, that means when we put the 2 equations in slope-intercept form, they'll be identical. So you'd have identical lines. So it'd be one line on top of the other, which would indicate that they have an infinite number of points in common. Our next concept is graphing linear inequalities and solving systems of linear inequalities. So primarily the concept is exactly the same as graphing linear equations with a couple of added things that you'll need to do. First of all, we want to put it in slope-intercept form. In this first example, it will be in slope-intercept form, but if it's not, we're going to change it. Secondly, if you look at the inequality symbol, if it's less than or greater than, then the points on the line are not part of the solution. So you would use a broken or dashed line to connect the points. If it's less than or equal to or greater than or equal to, points on the line are part of the solution. So you'd use a solid line. The second difference is that we shade. So the line that we draw is a boundary line. So the points will either fall on the boundary line and to one side or the other. So we shade the region where all our points in that shaded region would be a solution to the inequality. So how do we know how to do that? So let's go through this example. So the first thing I look at is I look at the inequality symbol and I look to make sure it's in slope-intercept form. So it's already in slope-intercept form, and I notice my inequality symbol is just less than. So I know I'm going to connect my points with a broken line. So the process is still the same. What I'm going to do is begin at my y-intercept, which is +1. My slope is -2/3. So from my starting point, I go down 2 and to the right 3 and put my next point. Now this time, when I connect, it's not going to be a solid line. It's going to be a broken line, indicating that the points on the line are not a solution. Okay, now remember what I said. I'm either going to shade below this line or above this line. because all of my solutions will be on one side or the other of this boundary that I just drew. So how do I know? There's a couple of different ways. Your book may have you do test points, which is perfectly fine. If you've put it in slope-intercept form, which we've done here, then I just look at the inequality symbol. In this case, y is less than. So what I do is I come to my y-intercept, which is +1, and I put my pencil on there. So I read from my y value. It says, where are the y values less than that point? Are they less than as you move up, or are they less than as you move down? Of course, they're less than as you move down. So my answer would include all the points in the shaded region. So I would shade below the line. We'll do a few more. So the next example, so again, first thing I do is look at my inequality symbol. It's greater than or equal to, so I know I'm going to be using a solid line to connect. But my inequality isn't in slope-intercept form, so I need to change it to slope-intercept form. And please pay attention. So again, I isolate my y. I'm going to subtract 3x from both sides. Notice my next step is going to be to divide by a -2. Remember your rules of solving an inequality. Anytime you divide by a negative, the sense, S-E-N-S-E, or the direction of the inequality sign changes. So it's only when you divide will you be flipping this, and only when you divide by a negative. So this gives me y. A negative over a negative is a positive, 3/2 x, and a positive divided by a negative gives me a -3. So because I divided by a -2, if I would have divided by a positive, I don't switch the sign. So now I go through the process again. I start at my y-intercept, which is -3. My slope is 3/2, so I rise 3 and run 2. I connect with a solid line because it has the or equal to. So that means the points on the line are a part of your solution. Now I shade one side or the other. I can use a test point, or I can look at my inequality symbol. I read from the inequality symbol. So since it says y is less than, I come to my y-intercept. The values that are less than are below. So I would shade below my line. Okay, in the next example, we only have one variable. And remember what we did before when we were graphing linear equations. If your variable was x, we had a vertical line. If your only variable was y, we drew a horizontal line. So in this case, we're going to have a vertical line that passes through every value of x, that's 2. So it'd be anything 2 units to the right. Now pay attention again to the inequality symbol. Since it's just greater than and not greater than or equal to, this is going to be a dashed or a broken line. Okay, since we're dealing with x in this case, I come to my x-intercept and I ask myself, where are the values of x greater than this? And as you move to the right on your number line, the numbers get greater. So I would shade the region to the right. So again, pay attention to the inequality symbol so you know what type of line you need to connect your points with. Now let's do a system. So what we're going to be interested here is the common shaded region. So when we draw the graphs of these two, remember the lines are your boundaries. So we're going to shade only one area, and the only area we shade is the shaded region that would have been common to both of these inequalities. So both of them are already in slope-intercept form. So I'm going to start by graphing the first. So again, I look, they're in slope-intercept form. I look at my inequality symbol. It's greater than or equal to, so I know it's going to be a solid line. So I start at my y-intercept, which in this case is -4. My slope, remember, it's understood to be 3 over 1. So I start at -4, I go up 3 and over 1. And so what I do with this is I connect it with a solid line. So that's my first boundary line. Where would I have shaded this? So I come to my y-intercept at -4, and it says where the y value is greater than. So what I'm going to do is I'm going to put the value 1 in the area where this would be shaded. So where you see this 1 would be the area in which would have been shaded. And you'll see why I do that in a second. So the next graph is y is less than or equal to 3/5 x. Remember again, since it's not shown, it's understood to be plus 0. So my y-intercept is at the origin. So my slope is +3 over +5. So from my origin, I go up 3 and to the right 5 and put my point. Pay attention to the type of line. Again, it's going to be a solid line. And where would I have shaded this second line? So it says I come to my y-intercept, which is 0, 0, and I would have shaded the region below since it's less than. So I'm going to put a 2 in the area that I would have shaded. I did this to illustrate the area that would have been in common. So you notice in this top area, there's only 1s. So I didn't shade the second graph in that area. So that's not my common solution. This area in between the two boundaries has nothing. So of course that doesn't have anything in common. This area here only has 2s. So that wasn't common to both. Notice this last area in here that I'm shading. That has both 1s and 2s. So my only solution, or the common solution, and this should be the only area you shade in your answer, would be this particular region here. Some people do it with colored pencils. Some people just remember where they shaded. Whatever method that you want to use so that you can identify the common region is fine. Okay, the next example. We have x minus 4y is greater than or equal to -8. So it's not in slope-intercept form, and I see the greater than or equal to, so I'm going to use a solid line. So I'm going to start by putting that in slope-intercept form. So I have 1x minus 4y is greater than or equal to -8. I'm going to subtract 1x from both sides. This gives me -4y is greater than or equal to -1x minus 8. Okay, now here I'm dividing by a -4. So remember what happens. I switch the direction of the inequality symbol. So this gives me y is less than or equal to, a negative over a negative is a positive. So that gives me positive 1/4 x, and a negative divided by a negative is a positive. So that gives me a positive 2. Now I have to put, I'm going to go ahead and circle this. Now I have to put the 2x plus y is less than or equal to 4 into slope intercept form. So I'm going to subtract 2x. So that gives me y is less than or equal to -2 over 1x. I didn't change the inequality symbol because I didn't divide by a negative. Subtracting is not dividing. So this would be my second inequality. So now we're going to graph. So we'll start with the first one, and we start at a +2 because that's my y-intercept. My slope is 1/4, so from there I go up 1 and over 4. The type of line is a solid line, so I'm going to draw a solid line through those 2 points. Now I look at how I shade. So I look at this inequality, and it's y is less than. So I start at 2. The values that are less than are below. So again, I'm going to put 1s here to show me where I would have shaded. Now I come to my next inequality. Y is less than or equal to negative 2x plus 4. So I begin at 4. That's my y-intercept. My slope is negative 2 over 1. So from my 4, I go down 2 to the right 1. I pay attention to the type of line. This is a solid line. So I'm going to have a solid line going through. Okay, I'm going to come to my intercept, which is 4. And my inequality says y is less than. So I'm going to shade everything below. So I'd be shading here and here. Again, because if you look at your line here, the values that are below would fall on this side. So what region do you see 1s and 2s in? It's only this area right here. You will only be shading one region.